Mr. Wolf, how are you doing today?
I'm doing good. Yourself?
I'm doing fantastic. My very first question that I have for you, if an asteroid hits the Earth, what are my chances of survival?
Your chances as a Millville teacher, if it hits anywhere near you, it's zero. Okay?
That doesn't sound too
Now,
promising.
No. But it really depends on size and speed.
Okay.
So the one that hit the dinosaurs is between 6 and 9 miles wide. Right? If you wanted to kill everything, you need something 60 miles wide. Right? About 10 times as big. Right? Now, luckily, 60-mile wide asteroids are easy to see coming. Not that you can get out of the way. And then it also depends, does it hit land or water? Right?
Oh.
If it hits the water, it's going to vaporize a good chunk of it, which is going to cause some wacky weather. And obviously, it'll create the largest tsunami ever, so San Francisco is going to have a bad time. However, hitting the ocean, for as bad as that sounds, is way better than hitting the land. And the big part, so let's just say it hits Australia, right? If it hits the land, the main thing that goes wrong is that it throws a bunch of dust into the air. That dust blocks a certain amount of the sun. You block enough of the sun, the earth cools down. You cool the earth down enough, you can't grow food, right? Because you cast yourself into a miniature ice age. And actually, this has happened not too long ago. In 1816, in Europe, Maine, and parts of Canada, a large volcano went off, which is a fraction of the destruction that an asteroid would cause, right? One of a significant size, right? Bigger than a football stadium, right? So one the size of a Volkswagen, destroys somebody's farm and nobody cares, right? But one the size of a football stadium, 6 miles, 9 miles, something like this, right? That is going to throw so much dust into the air that it's going to cause something like a 10 to 20 year winter, right? The one that happened in 1816 was just 1 year of no summer. It was just winter for 12 months, right? And it literally almost wiped out the entire population of Europe, right? Now, obviously, they were an agrarian society, right? It's not like they had food storage backed up, right? So we'd be better off today, but it would get ugly because of food supplies, right?
That really makes me not feel all that great today, Mr. Wolf.
But if you want to say, how do I survive an asteroid that, say, one that killed the dinosaurs 65 million years ago, okay? The way you would do it is, one, you can't be anywhere near it. Two, have some type of way to grow food without the sun, right? So hydroponics work in this way.
Yep.
But you would also need lamps that simulate UV light. Your regular lights aren't going to do it. You're going to need sun lamps and hydroponics.
Electricity?
And a way to generate electricity, right? So maybe a windmill or a water mill, or maybe you're just really good on a Peloton.
So after an asteroid hits, is there any radiation that I have to be worried about?
Well, there's 3 different varieties of asteroids. One is an icy body, no radiation necessary.
All right.
One is a rocky body, so the answer is maybe. So the ones that you have to worry about with radiation are the metal body asteroids. Luckily, those are the most rare. But a metal includes things like uranium, plutonium, rubidium, all those nasty things, right? So if those were to strike and vaporize themselves, some amount of radiation would be a problem. But in comparison to the food shortage problem, the radiation problem it's not going to be a Chernobyl, right?
Gotcha.
It's going to be secondary.
So let's just say that I have a bomb shelter from the Cold War era that has a pipe that leads to the outside just for air purposes. And it's not necessarily the best bomb shelter, but it's at least better than being in my house. Right. What are my chances of surviving in this bomb shelter for at least the initial impact?
as long as it doesn't land like in your county, decent, pretty good.
Yeah.
Right. Unless it's like a world ender, aka the 60-mile ones, then it just simply doesn't matter where you are, right? Because quite literally, if you get it with an asteroid going, the average asteroid is moving at about 20 kilometers a second.
Yeah.
Right? Not per hour,
Yeah.
a second. And if it's 60 miles wide, it's going to heat up the atmosphere. You know how like when you hit a nail, it heats up if you keep hitting it,
Yeah.
right? Just like the end of a jackhammer or a drill, right? You can literally hit something so hard it heats up. Well, a 60-mile wide asteroid hitting the planet would heat up the air so high that it would be like being in a broiling oven for, well, it doesn't matter. Any amount of time in a broiling oven is enough to wipe out all of the life on the planet. So that tiny little pipe circulating air to the outside world would be just enough to get you killed.
Wow, that is terrifying.
But luckily, those asteroids, at least in the asteroid belt, are pretty rare, right? Because Jupiter and the sun do you big favors. Because they're big, they have lots of gravity. Most of the asteroids in our atmosphere hit them and not us. And as a bonus, we also have the moon, which if you look at the surface,
We have our
isn't
craters.
exactly smooth.
Yeah, it's our man in the moon.
The moon helps a little bit more, but mostly you have Jupiter and the sun to thank.
With our current technology, if anything were to approach, would we be able to save ourselves?
If we could see it from far enough off, yes. Now, it's not going to be Bruce Willis Armageddon nuke it. Believe it or not, putting nukes inside of an asteroid is your worst possible scenario.
It craves shrapnel, right?
Right. You basically go from a missile to a shotgun blast, right? You actually make your job harder.
Who would have thought Michael Bay got it wrong?
Stunning, right? I know. Hollywood gets it wrong. Crazy. Believe it or not, if you can see it from very far off, right? And if it's a big one, you should be able to, right? You actually don't have to move it by much, right? Because small angles over large distances equal huge misses, right? And space is a pretty big place to begin with,
Yeah.
right? So big misses in the emptiness of space usually means things just go right by you. We get missed by stuff all the time, right? Just this year, there's been at least 4 large impactors that crossed in between us and the moon.
Yeah.
Right?
Yeah.
Now, the moon, you hear something like, oh, it was within, 500 kilometers of you. It's like, oh, that's super far away. It's like, well, in terms of space, it's actually right next door.
Yeah.
Right? The scary ones are the ones you don't see coming, right? And those ones are usually medium-sized, but extremely quick, right? Because not every place around the entire planet has the same type of detection,
Yeah.
right? Some countries have high detection, some countries have low. Satellites can't be pointed in every direction all the time. So it's the ones that sneak up on you. So if you could see it coming, you'd only have to nudge it a little bit without breaking it apart, and it should just completely miss you.
Well, I'm going to leave my faith to Elon Musk or Jeff Bezos to help us out when we need it.
Right. That's about where we're at.
Well, Mr. Wolf, you are very insightful, one of the most intelligent people I've ever met. Thank you for your time.
Thank you. I appreciate it.